Navigating Horizontal Scaling in ECS, Lessons Learned from Response Time-Based Autoscaling. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Understanding horizontal scaling in ECS. Horizontal scaling, or scaling out, involves adding more instances or containers to handle increasing workloads in a cloud environment. This approach in Amazon ECS, Elastic Container Service, is beneficial for maintaining application performance and availability during traffic spikes. As applications become more complex and user demand grows, horizontal scaling is critical to ensure seamless user experiences. Basics of horizontal scaling and its relevance in modern applications. Horizontal scaling is fundamental to modern application architecture, allowing systems to distribute workloads across multiple containers or instances. Unlike vertical scaling, which enhances a single instance's capacity, horizontal scaling helps distribute the load, reducing the risk of a single point of failure. This strategy is integral to applications hosted on ECS, where containerized workloads can be managed effectively across different environments. The test environment, simulating high response times. To understand the impact of horizontal scaling on response times, we created a test environment that simulates real-world load conditions. The objective was to observe how an ECS-hosted application behaves under high latency, often triggering scaling actions. By designing a mock application with deliberate delays, we aimed to mimic scenarios where response times might degrade under heavy load. Designing a mock application to mimic real-world load conditions. The mock application was designed to simulate a typical ECS deployment under load. We introduced artificial latency to observe how response times would affect scaling decisions. The application included simulated database queries, API calls, and user requests to reflect everyday operations in a production environment. Initial observations and the decision to scale. Initial tests revealed that the application's performance degraded noticeably as response times increased. Monitoring tools like Amazon CloudWatch indicated rising latency, triggering the decision to implement autoscaling. The initial hypothesis was that scaling out by adding more containers would reduce response times and improve performance. Monitoring tools indicate need for autoscaling based on response time. Using Amazon CloudWatch, we set up custom metrics to monitor response times closely. As expected, prolonged response times triggered scaling actions, adding more containers to the ECS cluster. The goal was to observe if additional containers could handle the load more efficiently, thereby reducing latency. Implementing autoscaling with custom metrics. We configured ECS to scale based on custom response time metrics to address the latency issue. This involved setting target response times, where ECS would automatically add more containers if latency exceeded the threshold. The implementation seemed straightforward, aligning with best practices for maintaining application performance. Configuring ECS to scale based on target response time. We were scaling based on target response time, which involved configuring ECS autoscaling policies to trigger when specific latency thresholds were breached. We set up policies to add more containers in response to high response times, anticipating that this would distribute the load more evenly and reduce latency. The unintended consequence, scaling without proportional improvement. However, as more containers were added, the anticipated reduction in response time did not materialize. Despite the increased number of containers, the application's performance degraded under load. This unexpected outcome highlighted the limitations of scaling based solely on response time metrics. Discovering the limitations of scaling based solely on response time. The experiment revealed a critical flaw in our scaling strategy. Response time alone was unreliable for autoscaling decisions. While response time is essential, it does not account for underlying issues such as database contention or network bottlenecks, which additional containers cannot resolve. Overloaded databases and the futility of additional containers. One of the key findings was that the database became a bottleneck as more containers were added. The added containers increased the demand for the database, exacerbating the issue rather than resolving it. This highlighted the futility of adding more containers when the root cause of latency lay elsewhere. Critical considerations for choosing scaling metrics. When considering scaling metrics, it is essential to identify metrics that correlate directly with user demand and system capacity. Metrics like CPU usage, memory utilization, and request count often provide a more comprehensive view of when to scale. Response time should be considered alongside these metrics rather than the sole indicator, identifying correlated demand metrics and their importance in scaling decisions. Correlated demand metrics are crucial for making informed scaling decisions. For instance, CPU utilization might correlate with increased user traffic, while memory usage might indicate the need for more resources. Combining these metrics with response time can implement a more balanced and effective scaling strategy. Conclusion: reflecting on the journey through practical ECS scaling. The journey through scaling based on response time metrics has been an eye-opener. While response time is a vital aspect of user experience, relying on it solely for scaling decisions can lead to inefficiencies and unintended consequences. Lessons learned and future directions in optimizing application performance. Response time as a secondary metric. Response time should be used with other metrics for auto-scaling decisions. Addressing bottlenecks first. Before scaling, identify and address potential bottlenecks, such as database limitations. Custom metrics for effective scaling. Utilize custom metrics that reflect the actual demand on your application to make more informed scaling decisions. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.